Okay, today we're going to be solving trig equations. You will want your unit circle for this. That's going to help you find the angle measures. Okay, so first thing we're going to get sine alone. So we're going to add 1 to each side. So you are solving just like you're solving for a variable, except in this case you're solving for sine of x. That's your variable. Okay, so sine of x is 1/2. So on your unit circle, all snow tastes cold. Sine is positive in the first and second quadrants. So you're going to be looking for an angle in the first quadrant whose sine is 1/2 or whose y coordinate is 1/2. And that is going to be a 30-degree angle. Okay, sine is also positive in the second quadrant. So look for a y coordinate that has 1/2, and it's going to be 150 degrees. Okay, so that's on just one rotation. So what if it was multiple rotations? Because with coterminal angles, I can have multiple rotations, but my angle end at the same place. Okay, so in order to account for that, you're going to add 260 times n degrees. N is for your number of rotations. So for example, if I want to do okay, so think about this 30-degree angle. So this is my 30-degree angle. But if I wanted to do one rotation and that 30 degrees, okay, so 1 would be the n, that would be a 390-degree angle, has a sine of 1/2. Okay, well, you can do an infinite number of rotations. So if I want to do 2 rotations, I'd be 2 times around the circle plus the 30 degrees. Okay, so then that 360n accounts for all those other possible angle measures. There's actually an infinite number of angles that would satisfy that statement. Okay, example 2. So on this one, we've got sine on 2 sides of our equation. Okay, I'm going to subtract sine and take it over here to the right. So I have negative root 2 equals negative 2 sine x. Okay, to get sine x alone, I'm going to divide by negative 2. So that reduces. So sine x is root 2 over 2. Okay, so again, back to your unit circle. Sine is positive, so we're looking in the first and second quadrants. So in the first quadrant, you're going to find a y value at 45 degrees. And in the second quadrant, it's going to be 135 degrees. So same thing. So x is going to be 45 degrees plus 360 n times n rotations. And it can be 135 degrees plus additional rotations. Okay, so there's your answer for all of those possible angles. Okay, number 3. So I'm going to subtract 1. So you get secant of x equals 2. Okay, now we don't normally think about secant being on our unit circle, but it's the same thing as doing the reciprocal. So if you found cosine of x is 1/2, those are the same statement. Okay, same statement, just written 2 different ways. So if I'm looking for cosines that are positive, okay, then I'm looking in the first quadrant and the fourth quadrant. So I'm looking for an x value that's a 1/2. So that will be 60 degrees in the first quadrant, and in the fourth quadrant, it's going to be 300 degrees. Again, add 360 n degrees to take care of any additional rotations and to include all possible angles. Okay, number 4. Okay, this time it's a tangent squared. So first thing I'm going to do is move 1 to the other side. So I added 1 to both sides. Now I'm going to divide by 3. So the tangent squared of x equals 1/3. Okay, we're going to square root both sides. I don't want tangent squared, I want tangent. So tangent of x is going to be plus or minus the square root of 1/3. So square root of 1 is 1, square root of 3, okay? So we have a radical in the denominator. All right, it's a quadratic, 2 solutions. So just like you were solving any other quadratic, you're looking for 2 solutions. Okay, now you most likely will want to rationalize this. Okay, so now we have tangent of x equals plus or minus root 3 over 3. Okay, again, well, this one you're doing plus and minus. So there's going to be 2 quadrants where tangent is positive, and then there's 2 quadrants where tangent is negative. So you're going to have 4 angle measures here. Also, remember, tangent is the y value divided by the x value. So you're going to have to look at your points, and if I do my y value divided by my x value, which one simplifies to root 3 over 2? Okay, and for us, it is 30 degrees. Okay, in the second quadrant, you can use reference angles. So in the second quadrant, a 30-degree reference angle is 150 degrees. In the third quadrant, a 100-degree or a 30-degree reference angle is going to be 210. And in the fourth quadrant, a 30-degree reference angle will be 330. Okay, again, you can have multiple rotations. So multiply by 360n, and that would include all possible angle measures. Okay, now on this one, there is kind of a shortcut that you can use. Okay, so there's my angle measures. If you think about what your coordinate plane looks like, so you have a 30-degree angle measure, okay, then, okay, so 30 degrees. Here's the 150-degree angle measure, okay, here's the 210. Now they all have reference angles of 30 degrees, and then here's 330. Well, look, you've got the 30-degree angle and the 150-degree angle are directly opposite one another. Also, the 150 and the 330 are opposite one another. So you could put like these 2 statements together, and you could say x equals 30 degrees plus 180 times n degrees. Okay, so you'd have your 30 degrees, but then if you add a 180, it takes you to this 150. If I add 180 again, it takes me back to that terminal side of the angle that's at 30. Add 180, takes me halfway around. So it's like you're stopping after each semicircle. Okay, then these other 2 share the 150 and the 330. So same kind of thing. I could then include and say 150 degrees plus 180 n degrees. So either way, you can write it, and you are correct. Okay, so those aren't too bad. Now we get to 5 and 6, we get a little bit more complicated. Okay, with number 5, notice that this is in factored form. Okay, you might liken it where we've solved other polynomials. So let's just say this is something like an x squared minus 4 times x plus 3. Okay, so for solving that, you are putting each of your factors equal to 0, and then you can solve. So square root both sides, x equals plus or minus 2. Okay, this one, x plus 3 equals 0. Solve it, x equals negative 3. Okay. So this one, even though it's a trig equation, this trig equation's in factored form. Okay, so you're going to do exactly the same thing that we just did with a regular quadratic. Okay, so I'm going to go tangent squared x minus 3 equals 0, and 2 tangent x minus root 2 equals 0. So I'm going to solve each of these. I'm going to move the 3 over to the right. So tangent squared x equals 3. Well, I don't want squared. I want just tangent x. So you're going to square root both sides, and tangent x is plus or minus root 3. Okay, on this other equation, I'm going to move the root 2 to the right. So 2 tangent x equals square root of 2. I can then divide by 2. And here, tangent of x equals root 2 over 2. Now, that's not a plus and minus, okay? My first one was because it was a quadratic, so plus and minus. Okay, so we are looking for a tangent, an angle measure whose tangent is square root of 3. Now, positive and negative, so you're going to have 4 angle measures. You'll have 1 in each quadrant. Again, find the angle measure in the first quadrant, and then you can use reference angles to find the angle measures in the other 3 quadrants. Okay, so tangent of x equals square root of plus or minus square root of 3. Okay, so let's do, so you have to think about y divided by x. So for this one, it's going to be 60 degrees. So x is 60 degrees. In the second quadrant, if I have a 60-degree reference angle, that's 120 degrees. Third quadrant, 60-degree reference angle, and that's going to be 240 degrees. And then a 60-degree reference angle in the fourth quadrant is going to be 300 degrees. Okay, now notice I did not include multiple rotations because if you look at the directions, I have limited your angle measures from 0 degrees to 360 degrees. Okay, tangent of x. So this time we are tangent's positive. So if tangent is positive, you are in the first quadrant and in the third quadrant. Okay, so angle measure in the first quadrant is going to be 45 degrees. That's your root 2 over 2. And then I can use a reference angle in the third quadrant if you want to, and you're going to get 225 degrees. Okay, so there's those 2 solutions. So you actually have 6 solutions to that equation. Okay, number 6. Factor this. You have a common monomial factor of a cosine. So cosine x you can take out. You are now in factored form. So this is going to be cosine of x equals 0. And this one's going to give you cosine of x minus 1 equals 0. So solve that. Cosine of x equals 1. Okay, cosine of x equals 0. So this is actually at 90 degrees. Okay, so your x, you're looking for an x coordinate on your unit circle. And that is 0. So 90 degrees, there's just that. Okay, so there's that angle measure, and then also at 270 degrees. So you have 2 angles whose cosines are 0. Okay, cosine is 1. That's going to be at 0 degrees. Okay, now some of you might say, well, it's at 360 degrees also, and you're correct. But if you go back and look at the interval, it is including 0, but you are open on 360, so you are not including 360. You're just including up to 360. So these would be the 3 angle measures.